Welcome, everyone. Welcome to our 10 a.m. session, Environmental Responsibility in AI. This is a chat with Kim Hazelwood, West Coast Head of Engineering at Facebook AI Research, and moderated by Morgan Lai, General Partner at Formula Ventures. Welcome, Kim and Morgan, and thank you for joining us.
Thanks so much for having me.
Cool, awesome. Well, it's such a pleasure for us to invite Kim to join us at the conference this year. So I actually met Kim last year at our AI conference in one of the networking sessions, and I've learned about her amazing past career, both on the academic side and also on the AI infrastructure side at Facebook. And then I think I'm going to turn to Kim to let her give a really brief introduction of herself, and then we will dive into today's topic.
Great, thanks. Hi, everybody. As Morgan mentioned, my name's Kim Hazelwood, and I've had a pretty dynamic career where I started out in academia as a professor at the University of Virginia, and then after tenure went on sabbatical out on the West Coast for Google, and never really returned from my sabbatical. And fast forward another 8 or 9 years, and I pivoted over to Yahoo Research, and then now Facebook and Facebook Research.
Yeah, so today's topic, so, as investor and as someone who had fairly deep prior AI background, I think today's topic is actually something I have never really thought of, was something that I've never really come across in the past few years. So why don't we start digging into what is this topic about the environmental impact of AI, and then how do you even come to this specific topic in the first place?
Yeah, sure. So I can actually pinpoint the exact moment where this became top of mind for me. So it was May of 2019 when I read a tweet from Emma Struble, and she said this. She said, "Are you interested in deep learning for NLP, but also concerned about the CO2 footprint of training? You should be." And then she had a table that showed that training one large transformer model along with a neural architecture search it used the equivalent CO2 emissions as 3 car lifetimes. So this was one model training. And honestly, after I read that and thought about it and realized that I was at Facebook, where we had lots of AI-based products, and there was a lot of training, not just NLP models, all day, every day by thousands of engineers, it really started to hit me. What is the environmental impact of all of that? And then, should we be more environmentally conscious? Should we think more before we push that train button? And are we doing anything egregious? Are we being very wasteful? And so I just felt like there was this turning point in my life where it was before I started to think about that, and then after I started to think about it. And then I realized that more people need to be aware of the environmental impact of what they're doing, because we're talking about AI for good, and it's super important that we're also not damaging our environment working towards the goal of doing AI for good, right? So that's kind of how we got started.
And then maybe you can share a little bit about any sort of new initiatives, or maybe specifically within Facebook, how do you guys go about becoming more aware of the environmental impact of whatever computational resources that you guys are spending on AI research or engineering efforts?
Yeah, sure. So I think one of the first things that we did was start to just try and get a handle on exactly how much training was happening, start to try to get a handle on what is the environmental impact of all of that. And, so I had already gathered a bunch of numbers about just the growth of AI at Facebook and throughout the research community. And some statistics that I was always sharing during my talks, really just to motivate building effective and efficient systems, were things like the fact that every year at Facebook, we were doubling the number of engineers who were working on AI. So basically their day job was to train neural models all day, every day. So that number was doubling every year. The number of models that each individual engineer was training was increasing per person as well. So every year we were having about a 5x increase in the number of models that we were training all day, every day. And then all of that resulted in an 8x increase in the amount of computational resources that were needed to do all of that AI training. And at first this was exciting because it seemed like, oh, look at this great growth and AI is, the future and everybody's working on it. And then that took a different meaning when I started to realize that that's not for free, right? That there is a potential, beyond our lifetime impact that we're going to see from that. So then we started to look into, okay, what is all of this training? Is all of this necessary, right? Are we being wasteful, right? And so, we started to look into things like we have pretty good visibility into all of the training that is happening company-wide because it all goes through the same FB Learner platform. So we have visibility about what all is being trained. And so one of the things that we did was we took one particular product and we looked at all of the different models that were being trained. And one of the things that we discovered was for that product, over 25% of all of the models that were being trained were absolute duplicates of something that had already been trained. Mm-hmm. So it was completely unnecessary compute and completely unnecessary CO2 emissions. Now, people don't do this on purpose, right? They're not, that doesn't make any sense, right? They're incentivized to advance things. So for the most part, people just weren't aware, right? And so that's like something that we could build into our systems where we could, detect duplication and just notify the person submitting the job, hey, you don't need to train this, your colleague trained the exact same model last week. Then some of this is also happening because people just want to learn. And so one of the first things people do when they want to learn, I want to learn how to train a model, they'll just kick off a big job that maybe trains on thousands of GPUs for a week. And that's a pretty significant cost of education. So it's almost like, I think they would learn just as much if you just mimicked that behavior, if you pretended to train, but don't actually kick off a 1,024 GPU job for a week, because that has a pretty significant environmental impact. So it was about raising visibility into the duplication that was out there, and then coming up with ways of letting people know, just raising awareness, but then also like detecting duplication and making sure that all of the training is much, much more efficient than it otherwise would have been. We had incentives to do that anyway from just a cost perspective, but having that visibility into the environmental impact was just much more effective. When people kick off a job, it'll tell them, our systems were already telling them how much this would have cost had we run this on a cloud provider. But that honestly isn't as effective as letting people know the environmental impact of that work, because money seems like, oh, who cares, right? But when it comes to the environment, you're not going to have too many people say, who cares?
Yeah, that's fair. So I think a lot of the audience most likely are very interested in thinking about how do they actually bring very similar type of like awareness or actually build similar type of like systems in-house. And then so I think one of the questions I want to throw out or ask you about is how does an engineering leader go about designing the system in the first place, and whether you have any suggestions about how do you even go about building this sort of like model monitoring systems, or how do you think about architecting it, etc.?
Right. So, I mean, I think that the key thing there, it's about raising visibility, making sure that everybody's aware of the impact of what they're doing. It's about detecting and flagging duplication, right? We already have demand control mechanisms in place because we already had more demand than we had compute capacity. And so this is just another, basically what we're really doing is controlling any of the artificial demand. That's an important thing to do, because I think for the most part, people try to design systems, but they assume that the workloads coming in are necessary, right? And one of the easiest ways to make a dent is to just not run something in the first place. So being able to detect that is going to be super important. And then, you know, there's another angle that I would love to riff on a little bit, which is that when we started to look into the sustainability of the whole end-to-end ecosystem, right? So, you know, we're really only dealing with the tail end at Facebook, right? We order servers and we're looking at what is the environmental impact of running those servers, leveraging those servers to run a workload. But what that ignores is an entirely, a whole timeline where all of the sourcing and all of the manufacturers, all of those components, like they've already produced a whole lot of CO2 emissions on their own from producing all of those servers and components. In fact, when we dug into it, the bulk now of CO2 emissions happens before it even shows up in our data centers, right? So it's just the process of designing and manufacturing all of those components that is producing a significant amount of CO2 emissions. And then the other thing is that when you look at the trends, so the trends at how many CO2 emissions that companies like Facebook, Google are using in their data centers, like we're actively working on reducing that, right? But what we saw was that on the sourcing side, it was a bit more flat, to where when you look at the overall contribution, it started to get to the point where manufacturing and sourcing was dominating in terms of CO2 emissions. So that is an interesting message for all of the providers of all of the components. And so that's like something that it's important that there's awareness there, and that everyone's holding everyone accountable for that environmental impact.
So I think going back to the topic of incentive, for which that you mentioned about, for instance, for engineers working at huge corporations like Facebook, they're just naturally not going to be as conscious about their energy spent on whatever model they're building, given that Facebook just has tons of resources to spend, right? And then you did mention about, hey, by actually referring whatever amount of energy that they're using, how that translates into environmental impact will actually create a lot more kind of like moral kind of like either guilt or constraint in kind of like regulating how they go about doing their engineering work. Might you be able to give us a few examples of different ways that you guys have been able to structure or present those incentives that make everyone actually align on this effort?
Yeah, so that is a super important point, because you know, people are smart and they're basically going to play by the rules that are in place. And so if they're purely incentivized by moving the needle on, you know, some AI model, there's nothing preventing them from just doing the shotgun approach of trying everything. Let me just guess and shoot in the dark. And so you do need some sort of control mechanisms in place. Well, one control mechanism that just naturally comes into play is that we don't have unlimited resources. So if you do shoot in the dark, you're going to have to deal with queuing. You're going to have to wait a while to get your results. But on top of that, even that isn't enough. And so that's why it's super important to have very explicit goals that are revolving around things like power efficiency, energy efficiency, minimizing the end-to-end latencies of all, your entire workload, right? Minimizing duplication. And so, we have pretty significant engineering pushes that revolve around reliability and efficiency. And so it's a very kind of ingrained into the Facebook culture that each half, there will be explicit goals on here's the amount of power savings and here's the amount of reliability improvements that we expect. And this is our way of incentivizing some of the things that just don't naturally get incentivized. And as much as I would love to think that just guilt is effective, it's really not. We can try, and we get to some people, right? Because we do show, oh, hey, that just cost the company $70,000 and used this many megawatts of electricity. That will guilt some people. But for other people, just having very explicit goals on, we expect the ads team to reduce their power consumption by X amount. This is a way to incentivize, environmental responsibility.
Got it. So previously you mentioned about you guys have been analyzing different part of the energy consumption throughout the lifetime of the model building process, from the hardware manufacturing part all the way to actually doing the software, kind of building computation. And there was actually also another question that just came in from audience that mentioned about whether does outsourcing data service or curations actually also have been calculated as part of this equation. So maybe you can give us a little bit of information on the breakdown of energy consumption throughout the lifetime of this process.
Yeah, so we had we just started digging into this, and so some of the researchers on my team pulled some data fairly recently, where they were looking at what are the trends, what direction are we moving in terms of building more efficient systems, using our systems more efficiently. And when we started to, there were a bunch of programs that have been in place in the systems research community to build more power efficient systems. And so the benefits of that have started to show up in terms of when we start to track how much energy is consumed per element of compute. The other thing that we were also tracking, though, was the sourcing pipelines. And that was something that really, I don't think we paid too much attention to before. All of the major companies will release these sustainability reports that let the world know, here's how energy efficient our data centers are. But all of those were really focusing on the capital expenditures and the operating expenditures of, from the perspective of that company, so that it started from zero from the day it came in the door. And the reality was that there was a lot of consumption that was happening prior to all of that, to where that was actually the dominant producer of CO2 emissions was happening before we even saw the hardware in-house. And so that was pretty interesting. And we looked at it in terms of mobile phones and sort of watched what the sourcing pipelines, those were actually going up, right? It was this kind of strange seesaw TikTok thing where it did seem like occasionally there would rein in consumption a bit. And then a new generation would come out and of a high-end phone, and it would jump again. So those are the kinds of things that we wasn't really on our radar. And because of that, when the various companies would talk about what is their energy footprint, they were ignoring all of that manufacturing pipeline. But more recently, we started counting it. And so there was a big jump in everybody's numbers a couple of years ago when we changed the accounting to where like we inherit the responsibility of all of the CO2 emissions that happens before. Then now we're incentivized to hold manufacturers accountable to having sustainable practices in their entire pipelines as well.
Got it, got it. And so I think previously when we kind of like talk about this topic offline, you did have mentioned about that there's actually some industry-wise movement for which like large corporations are becoming a lot more aware of the sort of like environmental impact that they have done from the sort of like computing consumption kind of like perspective. Specifically, Facebook and Google both have been publishing this sort of like environmental kind of like report. Maybe on a high level, you can tell us a little bit about what is this report is about, how this has been kind of like driving various different sort of like initiatives within Facebook. And then we can talk a little bit about how this report has changed over time, for which that is like aligned more with the sort of like in the new initiative that you just mentioned.
Yeah. So yeah, most of the major companies will have like Facebook has a sustainability team, and their primary role is to understand, track, and optimize the sustainability of the business. And every year they come out with a sustainability report from the previous year. So the 2019 sustainability report just came out a couple of weeks ago. And what that has is a breakdown of all of the different avenues that we're looking at in terms of, we're paying attention to the sourcing pipelines, we're paying attention to our operational usage within the company, we're looking at fair labor practices, all of the different things that you care about when you're thinking about sustainability. And so that's like a really great, breakdown of all of the impact. But then also internally, what that team does is then reaches out to various different parts within the company to hold those teams accountable for their part in building a sustainable business. And so I think one of the newer things that has really come out is where it hit me, the AI specific impact, right? I think there's a way to abstract this problem and just think about it as, we want to minimize compute, we want to build efficient systems, but there's special things that we can do from an AI perspective, and really starting with just cutting the fat and getting rid of the unnecessary training that we might be doing that otherwise would have been just assumed was useful work that, they would basically just have to do it as efficiently as possible, but hadn't really considered not training that model in the first place. And so that's like an example of one of the changes that, I've seen where you map like the abstract problem of environmental responsibility into a specific team within a company. And so that's like the part that I'm the most excited about, is I feel like we can make a pretty big dent really just by understanding and trimming some of the unnecessary computation that I think can make a pretty significant environmental impact. So, you can see these environmental sustainability reports, they get published on, all of the companies make a pretty big deal about it when they release them. And so you can dig in and see all of the different ways that we're tracking things. And, just the main thing that has changed recently is that accountability for the sourcing pipelines has definitely increased. And that I think is a good thing, because then it gives an incentive to hold everybody accountable.
Yeah,
for the end-to-end system.
So we are coming to the last minute of our session, kind of just like wrap up this topic. I think from the sort of investing kind of like perspective, we have seen tons of like startup like popping up, building sort of infrastructures around monitoring like model buildings or like helping with like pipeline management. So I think that part of the effort is basically getting accelerated and can potentially help with regulating the sort of environmental impact. And I think on the sort of the new effort around the environmental report, for which that you guys are start counting the carbon dioxide emission all the way from the manufacturers, producing hardware side, will also be a really, really good driver to actually help put some pressure on that industry around, really producing hardwares in a more sustainable way. So very exciting topic. And I hope that as an industry, like as a whole, this is going to be something that will be on the top of our mind when we are actually designing our systems. So thank you so much, Kim, for sharing this topic with us. And then I think we're going to pass this back to Irene for our next session.
Okay, thanks a lot.
Thank you, Kim and Morgan. Really appreciate it.
Thank you.
All right. So attendees, thank you for joining us and for your very insightful questions. It looks like there's a lot of discussion going on the Slido. So again, feel free to continue the conversation in our MIT CNC Slack channel. And if you'll be joining us in our next talk, please follow the link below the presentation stream, and we'll get started in 5 minutes at 10:30 a.m. So thank you all.
Thank you. Have a good day.